Let's begin with next chapter. Next chapter is about math operations. Mathematical operations, functions which are implemented in the PLC are, as you see, very useful and easy to use, but they have some dangers inside these functions. So we have to be careful using these mathematical functions, because sometimes we can make a really big mistake and it can be dangerous. So take first block for adding. This block looks very similar like other blocks, has supply for each blocks and has output. When this block is executed correctly, this output also will have the value of 1, like always. But here in this block you will see that this output have also some very important function, like some other block also. So to start, I will show you some interesting things. Right here, for first value MW0, I declare these variables a little before, because I would like show you something. So please only declare these values as I. So first variable MW0 should be a type of the word. So you can write here MW0 and choose the word variable in the default tag table. Second variable MW2, Y2, you should know that MW consists of 16 bits, so 2 bytes. So it is 0 byte, second 3 is second number of 2. And here we have got MW4. As you see that MW2 and MW4 has the variable type unsigned integer. So here we have got unsigned integer on output. Here we have got unsigned integer on output for input 2, and for first input we have got the word. As we can see it in the PLC tags, default tag table, you see these variables. For example, the names I will stay tag 1, tag 2, tag 3. But the most important is this, that we have got at the first word, and here we have got unsigned integer. When we prepare this program, please download this program to the PLC. When we have got this everything in the PLC, please at start click, of course, right button of the mouse, modify operand. If you remember, when we have got some bits modify, for example for these contactors, you remember that we can modify it to 0 or to 1. If we have some other variables which are not bit variable, but some bigger area of the memory, we can modify operand, and you have some like this table of our modified operand, that the address is MW0 and the name is tag1, and this data type in our system is word. Please first of all change the format of modify value from hexa to decimal, and write here, for example, value 500. Click OK. Next, please change here exactly the same, and for example, once again, or maybe 600, in order to have some differences. Of course, first of all, must be change this format to decimal. When we have got this, you can see that we have got here 600, sorry, and here we have got some strange number in hexa system. We can of course change it by clicking, of course, on the right button of the mouse, display format for network. We can check it for decimal, and we have got everything in decimal. Of course, when we check this exactly variable, we can display automatic or hexadecimal. Automatic will of course change to hexa. Now for a little break, I will show you how to change this format from hexa to decimal manually. sometimes maybe you will need it, so I will show you it in the some table in Excel. So how to convert our hexadecimal system to our normal decimal system? You can see here first main things of this hexa system. As you remember, in binary system we have got everything 2 to the power 0 to the power 1 to the power 2 and so on. In hexa system we have got the number of 16 to the power 0 to the power 1 to the power 2 and 3. I do not write it so for higher level of the power factor, because as you can see that 16 to the power of 3 is a really big value. Maybe 16 to the power of 4 is also useful, but in order to make it a little bit easier for explanation, I will show you only to the power of 3. So in hexa system, as the name of hexa is taken from this, that we have got 16 signs to code our binary system. We have got the signs from 0 to 9 and also A, B, C, D, E, F, which means exactly for A it is 10, B is 11 and so on up to the F, and it is exactly 15. So when we have got some number coded in our decimal in our hexadecimal system, for example, we have got here 22H. H, it is only for your information that it is hexa system. So what does it mean exactly 22H? As you remember on the first side, it is 16 to the power of 0, so it is 1, and this 2 it inform us how many times we multiply this first value on the first place. On the second place it is always 16, third place 256, and here it is 4096. So here we have got 16 to the power of 0. In easier way I show you only these values here. So we have got 2 to the multiply by 1, it is 2, and 16 multiply by 2, it is 32. So 32 plus 2 is exactly 34. And you can check also using calculator which is used in the our system, Windows system, and checked if it is correctly. If we have got another example, for example 13D, so it is our code in a hexa system. So at first position 1 multiplied by D. Remember, D it is 13, so 13 plus 16 multiplied by 3 plus 1 multiplied by 256. And when we do this everything calculate, we have got the number 317. The same, for example, only letters, B at first position, A at second position. So what we have got here from left side is easier to code it. So 16 multiplied by A, so multiplied by 10, we have got 160 plus B multiplied by 1, B is 11, so 160 plus 11, it is 171. You can see that it is correct. So come back now to our program. So now you know how to convert the hexa system to decimal system, but let's stay here in decimal system in order to easier understanding this program. So first of all, it is very easy. We add 500 to 600, we have a 1100. When we want to change this value to the value, first of all, very important, to decimal system, we change it to decimal, we can write 32,000. 32,000 through 600 is still okay. Here we can say the same value, 32,000. So it is exactly the same value. So now maybe change this value second for example 33,670. You can see now, first of all, that we have got some strange value 134, and as you see that we haven't got supply this NO output, so something is wrong. As you checked it in the instruction in the help function of the adding, you can read that the NO enable output has the signal 0 is if one of following condition is fulfilled. Check second condition. The result of the instruction is outside of the range permitted for the data type specified at the output. So, if you remember in MW4, so in word type, we can write only 2 to the power of 16 signs. If we checked in our calculator, I will show you this at calculator, we can make 2 to the power of 16, we have got 65,036. If we add this value, is exactly 60, and here we have got something wrong, that we have minus value. So it is something not okay. When we change this operand, because this unsigned integer, we can write value 32. Now it is okay. Format automatic, and here 33,000, it is 65, and now a little bit more, 3360. You see that it is 64. So why it is 64? Because we are over this value. Now it is okay, because now we have got here this value, positive value. If we change our display format to decimal, we have our minus value. This is what I have a little before. Why? Because in automatic format we have got detection of the sign, because the most important bit, it is sign bit, the same what we have got exactly on our calculator. In the programmist calculator, you can see that in programmist calculator we have got always the last sign. If we choose our, for example, word, this what we have got exactly now, the last sign is exactly the sign of minus. Here we have got plus, and here is minus. So it is very important to remember about this last sign. So now it is 64, because it is over this value of unsigned integer. So more than 65,000, this value 65,536. And now when we, for example, change the format, so it's not a problem, but if you remember, this value is word and this value is unsigned integer. If we change here the value, modify operand to, of course in our decimal system, to the value 32,070, we have got this value in accurate state, and here 2 to the power 8, we have got 256. So once again, 2 to the power of our word 16, divide by 2, so it is 32,768. So write this value exactly here in our decimal system. Once again, 32,070. We have our value minus. Why? Because in the word format it is not unsigned integer, because unsigned integer take that this whole word is without sign, so we have got 1 byte more. So we have got in our word type, once again, it is 2 to the power of 15, so it is this value, the maximum value which we can write here without any problem. And if we change the format to unsigned integer, so it is the most important in our declaration, so then we have got 2 to the power of 16, and we can write and code much bigger value. So it is very important in mathematical operations. In adding and subtracting, you can have a better view of it because you exactly know what you make. So the most important is declaration of such variables which we use for mathematical functions. In adding, it's not so big problem. In subtracting, so it is exactly the same. We can subtract and the block look exactly similar. But next, multiplication and division operation blocks are much more complicated, because there we multiply one number for other number, and this value is really can be really bigger, and we can faster overlap our range which we want to operate on it. And in subtract function looks exactly the same, so you can copy for example another variables and check how it will work. Subtracting the same like adding. The most important that subtracting here, it is input 1 minus input 2. If you do not know exactly how this subtracting work, always you can go to our help, subtract, go to help, and in the help you have always information how it will work. Here we have got example and the information how it exactly works. It's not, we haven't got here exactly this in mathematical function. Only in these brackets you can see that the output is input 1 minus input second. So it's everything for adding and subtracting.